Well, hi, good morning. Thanks so much for joining me here in my shop on June 26th. Want to know what year? 2022. So I'm in the process of changing capacitors. I've done a few. The capacitor tests show the capacitors are not in the worst shape. In comparison to many radios that I've done, these capacitors are actually in pretty good shape. Not like new, they're not perfect, but in terms of their internal resistance or their leakability, they're not bad. Nevertheless, the last few I changed in the output transformer circuit area seems to me to have resulted in a much brighter output and much more treble in the output. So maybe what I think is a kind of semi-okay capacitor really isn't. I mean, I need to recalibrate myself on this. That's why I do all the capacitor testing, to make sure I have a realistic view of the situation with each individual radio that I work on and the capacitors that I fill around with. I mean, that is the main problem with these radios. The main problem is old capacitors. Speaking of which, there are two more in here that I'm going to target today. These two are involved with the phono input. They're pretty hard to get a look at. Let's see if I can just swing this right around. Let me pull this out here. Way around, way around. So one is here. So one is here. And the other one is probably doing exactly the same thing. It's just buried way down deep out of sight under my finger there. You can't see it. There's two of them there. The size, so I'm just looking to see if I can see the size on it. Cannot, I can just see the voltage ratings. But it's quite clear that these are connected to this plug or socket. This socket on the back of the radio is labeled balance control. This one's labeled phono input. So the phono input and a couple capacitors connected to it. So I guess the signal that's coming from the record player is passing through the two capacitors that are here. And where are they going? I'm going to show you on a schematic in a moment. They're going through those capacitors and straight to a grid. More or less straight to a grid. So a leak in these capacitors might have an impact on the grid bias by drawing charge off the grid circuit through a leak back towards the cartridge. Don't know if that could really work or happen. I think it could. So we'll take a look at the schematic, and then I'm going to think about a more objective way of determining the effect of changing these two capacitors. One of them looks pretty easy, the other one doesn't look so easy. It's buried way down there, as I was saying. So why don't I take my time here, and take my time. Let's go look at the schematic. Okay, here's the schematic, and the stereo part of this, the two-channel part, is all this down here. And here we see some inputs. These represent the sockets on the back of the receiver. This one is the tape input. You can see the little tape symbol. Let me zoom in on this. Make it a little easier to see this stuff. Tape symbol here. No symbol here. And then a record player. Yeah, that's a record player symbol for here. So we plugged a record player in here. This is where the cartridge signal is being fed. One channel up and one channel down. We follow this one because it's on the screen. We see it encounters a large resistor, 500,000 ohms to ground. And then there's a capacitor. This is the capacitor I'm talking about. And then it's straight onto the grid. The interesting thing is this other input here. Now, this is labeled balance control. I'm going to guess that what you're doing is you're plugging in a potentiometer on a long piece of wire, so you can sit in your comfy chair and adjust the balance. And this was probably some guy's idea early on that faded away because I've never heard of a receiver like that, where you have a remote balance control that you can take to the comfy chair. But that's what this appears to be. So we pretend there's a potentiometer in here. The slider is hooked up to the ground, and as you adjust the potentiometer off center, you favor one channel or the other simply by drawing down the grid signal. Is that really what's going on? Or is this pushing the bias up and down on these two tubes and thereby changing the gain? Don't know. I don't know which way it's working, but I don't have the supposed remote balance control. There is no other balance control on this radio, which is really kind of weird. They really kind of went out on a limb doing this. I think you can see why this idea didn't persist. I mean, this is the only receiver I've ever seen like this. Yeah, I guess they tried it to find out. Now, another curious thing on the schematic is this. It's a little bubble. It's got it looks like a letter or a number in it. Here's the same thing on the other side. It's got a dot in it. Here's some more. 1. Looks like 1. Looks like 1. Looks like 1. Looks like what? Looks like an H. Looks like a G. So this must be referring to, I'm going to guess it's referring to test points somewhere in the schematic. Point G, you expect a certain voltage or resistance or something like that. I'm not really sure. Or maybe these are for, I was going to say alignment, but they can't be for alignment. They're on the amplifier side of things. The radio's all over here. Another interesting thing that's worth noting is the tape signal is fed basically into the grid of this tube through all this schmozzle. And it does not go through these amplifier tubes, or tube. This is a two-part single tube. See the dashed line here on that? What represents the tube glass, basically. Here it is here. That's the way they're telling you that this is really one tube from here to here. What is it? ECC 83. So what would happen if these capacitors are not good? So if this is nothing more than a big resistor here, or a resistor and capacitor in parallel, which is kind of how you could model a leaky capacitor, then whatever potential is building, let's just see how they're doing here. Now they have what looks like a cathode resistor arrangement here. 8K, 12K, about 50% voltage divider. I don't know what they're doing exactly. But it looks like some of what they're doing is they're raising the cathode potential to provide a tube bias relative to the grid. But at the same time, there's a large 1 meg resistor here, and you got to fight your way through it to get to ground down here, or through this one to get to ground down here. And I guess that puts a leg of the balance potentiometer in parallel with this thing. Anyway, I kind of lost my train of thought there. I was talking about the self-biasing effect here. So if this is leaky enough, you could leak charge. Here's a 500,000 ohm resistor to ground. You could leak some charge off this way. I don't know. What would happen to it going through the cartridge? Would it go through the cartridge? I don't know. So these are the two I'm going after anyway. Now what if their capacitance is lower than it should be? So if the capacitor's gone haywire, I would think all it can do is reduce the amount of signal getting through to the grid. Can't see how it would go any other way. So that's a possibility, and that would cause an imbalance. Also, because you have no reason to think both these capacitors are identical. You've already seen that in one case. Two capacitors doing the same job, testing differently on the capacitor checker. So this could cause a balance problem, and without the balance control, you can't balance back against it. Yeah, so these are worth doing. Now I got to think of some way to make an objective test here. I'm just going to think about that for a little while. Well, it's taking me quite a while to come up with a way to feed some white noise, or a hiss, let's just call it a hiss, into the radio so I can hear what it sounds like, and then as I make changes I can hear how that changes. Change the capacitor, what happens. Keep track of that. I think what I'm going to do is I'm going to try to feed exactly the same signal into both phono channels, the hiss. Check it to make sure it's balanced and sounds kind of the same. Even that's tricky because my speakers could be a little different, so there's lots of ways to get this wrong. Lots of ways. I do have this interesting connector. Surely to goodness, two of these are going to mate up with the phono input. Put that back in. This is my source of noise. Just an FM radio tuned between stations to give a nice white noise. I had another device in here which promises to produce white noise. I wasted my time with that. So, a mono input into the radio, speaker out, and then I'm going to attach these on here. I'm going to figure out which one of these is, which two of these are the left and right channel, and get that going. Okay, so I can do this on video for some of the connectors. I have quite a set of various audio connectors that I can mess around with. Just noticed another cable I have. We'll go with this. These cables, these might have trouble. I don't know. I've checked this phono cord. It's good. Okay, radio on, or phono on is what I really want to have happen here. Are we all set? Are we set? Can I turn this on? Not be scared. Let's just watch the lights. Double check. I don't have the power plugged in. It's not gonna be able to jump that distance. I better plug this right in here. Okay. This, by the way, is a little device I use for checking the continuity of cables. What a great thing. Found this in the bottom of a box I bought at a yard sale. Hey, just for me. Okay, we'll turn this on, get some volume. Okay, now his signal should be on both of these wires. Are we ready? In fact, we could put it into the tape input and kind of get things sorted out. Don't want too high a level coming in. That's okay. Okay. Just trying to make sure I'm thinking of everything here. So we're going to go on. We're going to start with the AM radio. Make sure everything is working first. Here we go. Volume is right down. We'll turn it up a little bit. Okay. Bit of a slow starter, this radio. Very slow. Slow, slow, slow. Well, I hear that sound, that ticking sound. It sure seemed to relate to the warming up of this radio. But I hear this ticking sound all the time on different radios in my shop here. Sure sounds like it came out of here though, eh? The way it started, very, very slow. Well, I'm going to ignore it. Okay, FM radio's working. We're good. Volume down. We'll switch over to phono. That's this input. Turn it up a bit. You hear nothing. Very good. Now we're going to start guessing. Turn this up a little bit. Okay, I heard a speaker make a noise there. Green, maybe. Nothing. That made a little noise. So it looks like it's the black and the green. Okay, we're going to go in. radio noise source here. There it is. And there's a little bit of hum. That's good. That's good. Because not only is the high end potentially affected, the low end can be affected if the capacitor has those capacitors have lost their capacity. I would think the low end would start disappearing. Very good. Now, let's see if we can get a little bit better noise and less station here. Okay, so no station there. Nice noise. Is there a treble control on here? Leave it high. Wish it was a little higher yet, but we got what we got. Tone controls out front. There we are. Oddly enough, the tone controls on the front, the bass and the treble, you turn them up this way. It's not this way. It's kind of weird. You turn up the bass by going this way and turn up the treble by going that way. Now we're good. Down on the volume. Very, very good. Now somehow I have to get, well, I was going to say I have to get a memory of the way it sounds now, and then I have to leave everything exactly the same, change one capacitor, just one, and then I have a left-right comparison I can do. Let's do that right now. Now I am using speakers, and the only way I can do it is by popping this in and out. That's one speaker. Oh my gosh. Oh my gosh. What is happening there? Oh, completely different. Wow. Well, this has highlighted a big issue here. The one phono channel is just muffled right out. Can it be something I've done here? It could be. It could be that maybe it's supposed to be in the. Maybe I got this wrong. Doesn't seem like it, does it? That sounds kind of normal to me. That sure doesn't. Plug that in right. Wow. Well, it could be these capacitors. It could be the two little capacitors right down here. Okay. Now if I had a balance control, I'd be able to flip it back and forth quite easily, but there's no balance control. Why don't we put this into the tape input? Tape input's here. This can go right over here, and we'll listen to what it sounds like coming from the tape input. Good thinking. Good thinking. Volume down. I'm gonna guess it's the same wires. Maybe not. Volume up. And I gotta push the tape button. I'm gonna rely on reading this upside down. Ooh, what was that sound? Just nothing important. So this is on the button. It's on the stereo setting. It says pick up and tape. So we should be good here. A little more volume. A little more volume. There it is. Oh my gosh, it sounds the same. Okay, we're going to go to the other channel. This is really revealing something here. Oh! Did I get these mixed up? They're different. That's what it is. They're different here. So here it's the red one, and the black one, not the green, not the yellow. Who knows what I'm plugging into there? Same channel, just totally muffled out. Oh my God, is this because of something I did? These capacitors I changed? Well, there's a long list of possibilities here. Oh my gosh, okay, wasn't expecting this. Turns out to be an extremely valuable test. Is it just possible it's my speakers? I don't think so for a minute, but let's flip them. So right now, we're listening to this. We should hear the same sound out of the other speaker. Yep, it's the same sound, a little quieter. Okay, it's not the speakers. It's not the input. It's something beyond the tape input. Oh. Okay, so I gotta stop and ponder now. To some degree, this test is indicating the capacitors over here are good because they're relaying what I think is a full signal until you hit the problem spot, which is probably over here, somewhere over here. Okay. I can't see there's anything wrong with the setup I've done here that would cause this. This has to be the receiver. A really easy thing to do is to swap those two output tubes. I wouldn't expect that to do anything, but you know, easy's on the top of the list here. Okay, let's shut her off. Let these cool down so I can handle them. We'll switch them just to be sure that it's not from the tube. I'm not even sure how a tube could do exactly that, but let's just eliminate that. Okay, if you hear a bit of a roar in the background on the video, it's my house air conditioners. Come on. I'll switch these. As I said before, I don't expect this to have any effect, but who knows? Okay, there we go. Okay, power back on. Now, I don't know what you can hear on the video or how the left and right channel is working out on the video. I'm using a stereo. They're just a stereo microphone straight above my hand here. So I'm hearing the defective sound from the speaker this way, and the good sound was coming from that way. Okay, so I am hearing the defective sound from up there. So switching these has done nothing. Not surprising. Now, there's a couple other dual tubes in the line of the signal coming through here. One of them I think is over here. Oddly enough. Maybe not oddly enough. So radio the same way. I don't have a balance control but I can disconnect speakers. I don't think the radio was muffled out like this. I never noticed it. Okay, let's switch to the radio and we'll see. That certainly doesn't sound muffled out. I'm hearing it out of both channels. In fact, they sound like they're not they're not synchronized. They're not they're not doing this. They're doing this. Let's just cut out this one. So I hear lots of treble coming out of there. Well, that seems to narrow things down quite a bit. The next step is to look at the schematic and try to come up with localizing where this issue might be happening. Yeah, That's what we got to do next. Okay, this is my third shot at recording this little bit here in the video. I don't normally go back and redo things, but first time I talked about the schematic, I had the wrong camera up and I didn't show the schematic. Second time I just finished doing it, I didn't have the correct microphone on. So here we go again. So what's the deal here? One channel muffled, other channel not. When the signal comes from the radio, it sounds fine. So let's figure that out. Where's the signal coming from the radio? So we can look at the detector tube here with the diodes in it. And we can guess 2 of these diodes are involved with the FM side of it, and 1 diode is the AM detector. I already pointed at them. These 2 here are connected over here. This is almost certainly the FM. This is the FM detector here. So that leaves this one as an AM detector. We follow this down. There it is, going through the final IF transformer here. So for sure, this is the AM detector. So now down here we would find the audio signal and a DC voltage. Come down a little further. We see this line going in 2 directions. One direction is this way past a very large 1.5 megohm resistor. This is the AVC line, and on this side very high impedance, and there's a capacitor there to affect the operation of the AVC and probably eliminate any audio that might still be in here. Now we go the other way because we're not too interested in this way. We go the other way and encounter a switch. So this line is the AM. This line here is bound to be the FM. Sure enough, there it is coming out. Some various filters on it. And so if this switch is set this way, it's AM. This way, it's FM. And open would be tape. I don't know. You know, they don't really show this pictorially as well as they could. I think they have a chart on here somewhere showing all the switches and all the... Yeah, here it is here. I have to study that for quite a while to sort it out. I would anyway. I'm not going to do that. So go back here. Detector. Here's the switch. So with the AM running, AM audio output comes here. Still carrying the DC. Oh, bangs into a capacitor. So the DC ends here. From here on in, it's audio. Clear, sharp audio. Now that is fed upwards here. Up. So you could assume that this switch, when it's set between 8 and 9, is for the radio. AM or FM. And from here on in, it's all good. It all sounds good. So it's when the switch is flipped to tape and phono back this way that we have trouble. Now we know it's both the phono and the tape side of things. So we know it's not these tubes, it's not the circuitry in these tubes. These are only operating when the phono, or only used when the phono side of things is running. Where you have a phono input, let's put it that way. Well, that's pretty interesting. Now, if this is the balance, something else just come to mind. If this is the balance control with a potentiometer in here, and the only thing that it's balancing is the phono input. The tape input are on these 2 pins, 3 and 5, these 2 terminals. 3 up, 5 down to the same spot. 1 channel muffle. So how can it be, looking at this switch, that if you connect here, you get a nice clear signal if you take it from the radio, but if you take it this way from the tape, 1 channel muffle. What could that be? I mean, the signal's coming straight up here. The only thing it could be, in my mind, is this capacitor, which is going in the wrong direction. The signal's not meant to go back this way. Excuse me. The B plus is on this tube, 150 volts sitting on one side of this capacitor. If this guy's in bad shape, there's another one down here. If these 2 guys are in bad shape, or one of them's in bad shape, and leaky, then you would get some portion of 150 volts building up over here. And I notice there's nothing really to draw down except the internal resistance of whatever it is you're plugging in here. In my case, the last thing I plugged in here was my little radio. I think I stuck 150 volts into that little radio. Doesn't look like it. So, can this be responsible in some way? I don't know what else it could be at this point. So I think what's called for here is a little more signal tracing. Listen to the signal on this side and then on this side with the phono running, that kind of thing. And maybe we can track it all down that way. But I'm going to call it quits for today because it's well into the afternoon now. And I got other things to do. And so I think this will be quite interesting tomorrow. I managed to localize this pretty well today. That's good. So thanks a lot for watching. And maybe you'll see me tomorrow. Bye.